Did you know that the coldest place in the entire universe is not the dark void between galaxies, but right here inside a modern laboratory? Out in the vastness of space, temperatures drop to a freezing minus 270 degrees Celsius, but we have gone even further than that. To build the most powerful brain in human history, we must conquer the ultimate limit of thermodynamics known as absolute zero, hidden deep within our labs. This giant golden chandelier is actually a dilution refrigerator, a machine capable of cooling quantum chips to temperatures colder than the depths of the cosmos. Inside this vessel, the temperature plummet until it reaches nearly 0.01 Kelvin, a state where all atomic motion practically comes to a halt. At minus 273.15 degrees Celsius, we enter a realm where the laws of physics as we know them begin to change completely. Our scientists work in sterile environments, carefully managing every tiny wire and connection to ensure the stability of the fragile quantum states within the machine. This journey to the absolute zero point is essential for the birth of quantum computing, a technology that will soon redefine our entire digital world. Welcome to the frontier of science, where we are learning to manipulate the very building blocks of reality to solve the impossible problems of today. Every adjustment must be perfect, as even the slightest heat can destroy months of work in an instant within this ultra-sensitive subatomic environment. By reaching absolute zero, we create a quiet stage for atoms to perform, allowing us to harness the strange and powerful rules of quantum mechanics. In our current world, every computer uses classical bits, which are like simple switches that can only be turned either on or completely off. This binary system of 0 and 1 has powered our technology for decades, but it has reached its physical limits in terms of processing speed. Enter the qubit, the heart of quantum computing, which can exist in a state of superposition, being both 0 and 1 at the same time. Think of a spinning coin. While it rotates, it is neither heads nor tails, but a blur of both, representing the magic of quantum superposition. This allows a quantum computer to explore every possible solution to a problem simultaneously, rather than checking them one by one like traditional machines. Then there is entanglement, a phenomenon where two particles become linked, so that the state of one instantly influences the state of the other. Information in a quantum network does not just travel through wires. Yet it exists in a connected web where data can move with incredible synchronization. This incredible architecture allows for a level of parallelism that was once considered science fiction, opening doors to a new era of human intelligence. A quantum computer can handle massive amounts of data in the blink of an eye, performing calculations that would take today's supercomputers 10,000 years. When the computation is finished, the spinning coin stops, and we are left with the most efficient answer to the world's most complex challenges. We are no longer just using electricity to think. We are using the very fabric of the universe to process information at the highest level. Each new qubit added to the system doubles the power of the machine, creating an exponential growth in our ability to understand the world around. The engineering required to maintain these states is mind-blowing. It's requiring materials and precision that push the limits of modern manufacturing technology today. Why do we use gold? Because it is one of the best conductors of heat and electricity, essential for maintaining the ultra-cold environment required. This machine uses a sophisticated mixture of helium-3 and helium-4 isotopes, circulating them through a series of chambers to strip away every bit of heat. The process of cooling is a delicate dance of fluid dynamics, where liquid gases are used to reach temperatures just above the absolute zero mark. These wires act like the nervous system of the computer, carrying fragile signals without generating even a single microscopic spark of disruptive heat. At room temperature, atoms are constantly shaking and bouncing. To a qubit, this vibration is like a loud noise that destroys its delicate memory. We must build a fortress around our processor, shielding it from Earth's magnetic field and the invisible radiation that surrounds us every single day. Every component is designed to be a silent guardian, protecting the quantum information from the chaos of the outside world that wants to destroy it. The engineering feat is not just in the cooling, but in keeping the system running perfectly for days, weeks, or even months at a time. Once the machine is sealed, it becomes a world of its own, a place where time and space behave differently than anywhere else on Earth. The physics of superfluids allow the coolant to flow without friction, reaching every corner of the processor to ensure absolute temperature uniformity throughout. This is the most complex refrigerator ever built, costing millions of dollars and requiring a team of world-class experts to operate and maintain. Every layer of gold foil serves as a mirror, reflecting heat away and ensuring that the inner core remains as still and cold as possible. In this perfect silence, the qubits can finally do their work, unburdened by the heat and noise that limit the computers we use today. This is no longer just a scientific curiosity. It is a global race for technological supremacy between the world's most powerful nations and corporations. IBM has pioneered the accessibility of quantum computing, allowing researchers from around the world to run experiments on their cloud-based quantum systems. Meanwhile, Google shocked the world by announcing they had achieved quantum supremacy, performing a task that was impossible for any classical supercomputer. Governments are pouring billions into this field, knowing that the first nation to master quantum technology will dominate the global economy and security. The competition is fierce, as scientists work day and night to increase the number of stable qubits and reduce the error rates of their machines. Quantum computers pose a major threat to current encryption methods, potentially rendering all of our modern digital passwords and financial records completely vulnerable. On the other hand, they could revolutionize the financial sector, allowing for perfect market simulations and the optimization of global supply chain networks. We are witnessing a new kind of arms race, where the weapon of choice is not a missile, but a processor that thinks in qubits. From China's satellite-based quantum communication to Europe's research hubs, the quest for the ultimate computer has become a truly international endeavor. The winner of this race will hold the keys to the future, controlling everything from secret communications to the discovery of life-saving medical treatments. It is a battle for the next century, and a turning point in history that will change how we live, work, and protect our most valuable information. Every breakthrough brings us one step closer to a world where the word impossible no longer exists in our scientific and technical vocabulary. The race is heating up, even as the machines themselves stay at the coldest temperatures ever recorded in the history of the entire universe. In the world of medicine, quantum computers will be able to simulate every possible chemical reaction to create new vaccines in just a few hours. Diseases that have haunted humanity for centuries could be cured by unlocking the secrets of molecular biology through pure, raw quantum processing power. Artificial intelligence will reach a new level of consciousness as quantum processors allow machines to learn and reason in ways that mimic human thought. This quantum-enhanced AI will solve the most complex climate models, helping us find the perfect balance to save our planet from environmental collapse. Smart cities will run with perfect efficiency, reducing waste and energy consumption to near zero levels thanks to quantum optimization of every single system. We will discover new materials that are lighter than air and stronger than steel, revolutionizing everything from space travel to everyday construction. Space exploration will enter a golden age as we use quantum calculations to chart safe paths through the stars and reach distant worlds faster. Weather forecasting will become a perfect science, allowing us to protect communities from natural disasters before they even have a chance to happen. The line between the physical and digital worlds will blur, creating experiences that are limited only by the boundaries of our own human imagination. And this technology has the potential to end hunger and poverty by optimizing the world's resources so that everyone has exactly what they need. We are building a legacy for the next generation, a world where the challenges of today are simply the solved problems of the past. The quantum revolution is not just about faster machines. It is about expanding the potential of what the human race can achieve together. Together, we are stepping into a future that was once only found in the pages of science fiction, making the impossible a daily reality. As we stand at the threshold of this new era, we realize that the greatest breakthroughs are born from our deepest curiosity and tireless effort. This machine is more than just a computer. It is a monument to our desire to explore the unknown and master the laws of nature. Inside these ultra-cold chambers, we have found a way to speak the language of the universe, unlocking a power we are only beginning to understand. And the impact of quantum computing will be felt in every home, every business, and every corner of our planet within the next few decades. We are creating a world that is more connected and more secure than ever before, powered by the incredible speed of quantum mechanics and entanglement. This revolution is happening faster than the birth of the internet, and its consequences will be even more profound for the human species. We are pushing the boundaries of our own limitations, proving that there is no horizon we cannot reach if we have the courage to try. The quest for absolute zero has brought us to the brink of a new world, a place where the rules of the strange become the tools of the wise. The future is no longer a distant dream. It is here, vibrating in the silence of these subatomic machines, waiting for us to take the lead. We are the architects of this new reality, and the journey we have started will lead us to places we have never even dared to imagine. Oh, the race to conquer the absolute zero and master the quantum world has only just begun, and the best is yet to come for all of us. Thank you for joining us on this journey through the coldest place in the universe and into the heart of the future of human intelligence.